We've done everything by hand, but an important thing is we don't have to do all these things by hand. We have the ability to use a computer. Most modern computer programs will do this for us. So I'm going to go into data. Make sure you've installed the data analysis package if you want to do this. We plug it in and then we go with t-test to sample, including assuming equal variances. Put this in. Variable ranges, just click on the column to get all that. Make sure that there's labels. We always have to put in 0. We'll just leave that alone. New worksheet, press OK, and we'll put in 0. And now we have our to sample assuming equal variances. Notice that we got the same t critical, and we got the same test statistic. But one thing you might notice is that it also gives us the one-tailed, and it gives us p-values. P-values we have seen before are really, really important. Here, p is 0.000257. That is definitely smaller than 0.001. It's a very small p-value when we assume they're the same. Now we can do the exact same thing, only if we want to make it unpooled, we'll do the exact same thing in the data analysis package, but select assuming unequal variances. Variable range 1, 2, labels, hypothesize mean difference, I'm leaving as 0. Alpha is still 0.05. Click in, and we get a different p-value. Very similar, but if you look at our new p-value, it's a little bit bigger. That's because the unpooled one is going to be a more conservative test. It will always be just a tiny bit bigger. So look at those next to each other. You can see that we have similar but different test statistics. Similar, 21 versus 25, but different degrees of freedom. Most importantly, when I talk about the p-value, it's always going to be slightly bigger if we assume unequal variances. Thank you for listening.